Hi everyone, welcome back. Lastly we learned about D3s and today we are gonna start a new one which is SVM, which is standing for support vector machines, and also at the very beginning we learned about kernel, then D3s, and now this SVM. And between those, SVM is the most important one, I can tell you. And in this video basically we are just gonna see how this SVM is working and why it's used. And in the next video we are gonna focus to the parameters, and also I want to start to a new one which is we already did in the previous modules. I want to compare each new ML machine learning class of OpenCV we are starting. I want to compare them in a table, so each new one we start I'm gonna add them into here. So basically we learned these three for now, and let's go through on this. Type is discriminative, decision tree and SVM, and but kernel is not. Basically by discriminative I'm meaning is that SVM and decision tree is kind of learning. What I mean is that SVM is getting the data, and Y on data is calculating some parameters and functions, and it's learning the data. And similarly decision tree is just updating its nodes. So these are Y on the data, they are kind of learning. Kernel is not learning. Even I write here lazy learning, but it's not learning because each new data comes to the kernel, it goes through all the data again and calculating based on the distance. So yeah, these two are basically for learning, but kernel is kind of different. And speed is since about training SVM is slower and decision tree is faster comparing to the SVM, at least kernel actually does not learn. So yeah, we can say it's very fast. Speed, yeah, once it's trained it's really fast, this is fast, but kernel is, since on runtime it's gonna be slower because it will always check the data set. And memory use low, medium and high. Handles non-linearity. This is the most important one in here because SVM is mostly used for non-linear data set. Of course it is also capable for linear data set, but yeah, it's important for non-linearity. What I mean by non-linearity, you will remember in the kernel part we have three clusters, let's say, grouped. Then we can easily separate them with one line. So this is linear group, but non-linearity, I'm gonna show you in the code part an example which is totally about non-linearity, so you can understand in there. Yeah, but these are still supporting, of course, non-linearity, but not directly. Yeah, non-linearity in a huge area, these are just small part of it. Visual intuition is intuition, you mean something is coming, okay, this you can decide faster, right? This is kind of intuition. So kernel is easy because a new data coming, okay, you can easily tell even this is belonging to here. Decision tree is also kind of going to the nodes, so it's also easy. But SVM, because of the nonlinear data set we are talking about, is not really easy to decide. Overfitting risk, medium, high and high. Best for, yeah, this high dimensional data, this is really good. kernel is for simple problems, is good. And yeah, this is also fast splits for, yeah, but I'm not gonna use decision tree for high data set because decision tree not really many nodes is gonna have some problems about the speed, about the efficiency. So yeah, basically this is the table and you can check this later. And we can go to the code part. And here basically I have a code, but do not be afraid, I already closed it. I will not show this one to you because all this is just doing creating my data, yeah, here. So maybe we can split. I already coded this, I don't want to scratch because I don't want to distract your mind. This SVM is important and it's simple, don't be afraid. Until here we are just creating an image which I want to visualize my data, and this training data and the labels you need to check the previous video if you are directly watching this, because this part you will understand according to the previous video. I will not talk about them again. And this generates circular data. Let me run this again. So you see here the one data inside and the other one is the around, outer and center. So this data is generated by this function. This function is only generating this data, nothing else, so don't focus that part. And also you can see now here this is a non-linear group of data sets, so you cannot separate this with only one line, so it is a non-linear data set. And we are creating SVM. Also, do not focus these functions now because we are gonna learn these in the next videos detail. I'm just doing that to explain you a basic usage of SVM. And this train also, we are giving the training data and labels and the raw sample we already talked. These also in the D3's video, you can check it. And I will skip this for loop because this is just putting those dots you see on the im show. They are just putting the data into its outer and the central data. And this we are putting a text to show which class belonging to those circles. And there are two test sample I'm using. The first one is we are giving the coordinates 250 to 250, which is the center of the im show, center of the image, and we are predicting it, and it's giving us the integer, which is meaning the class ID of that predicted sample. And similarly for 400 to 250 coordinates. And that's all. And we are drawing the circles, those samples, and we see the result. Okay, this is belonging to the class 1, which is center, correct, and this belonging to the outer one. And yeah, this is like that. We can change it actually. Let's make this 300 maybe. Also let's change here to see 300 to 250. Now you see both is belonging to the class 0, which is outer ring. So SVM is basically doing this. Of course, this is a very simple example I showed you about nonlinearity, but I should show you something which you can understand about the visualization. For more complex things, maybe in the next videos, in new projects, we can go on through them. And for this video, simply I just wanted to show you the comparison of SVM with kernel and the D3s we learned, and also how we are using SVM. Yeah, and I'm done for this video. Thanks for watching. See you in the next video.